Hey everyone, my name is Isabella, and this is a quick demo and explanation of a simple iOS list app created in Swift. I will be highlighting some of the main structures and features and demonstrating the tests used. So here's how the app looks like. It's a list of the top 20 national parks in the world, accompanied by a picture, name, and country descriptions in each cell of the list. When you click on a cell, you're taken to the next page for more information, and this contains a larger sized image, rank, visitors per year at the park, and a short description. So the code is structured as such. We have two view controllers over here. We also have park cell, which manages what you see in each cell on the main list page. Data is retrieved and managed using the data models park service and park, which is where we'll start. The basic data flow starts from park service. This gets data from this mock URL, which contains a JSON containing all the information needed for each park. So this is the URL, and if you click on it, this is the JSON that you'll see, and each park has the following attributes: name, country, image, URL, rank, visitors per year, and description. We have all of these attributes for each park entered into the park data model, as you'll see here, and we'll have an array of all the park objects in park result. From there, we retrieve just the park name, country, and image for each park cell, which is over here in parkcell.swift. We also retrieve the park name, rank, image, and other details for when you click onto a cell in the detail view controller, as you see here. So I'll briefly go over two features, error handling and the activity indicator. Moving back to parkservice.swift, in here we have a list of possible errors in case of any problems with retrieving the JSON data. And we also have an accompanying localized error message, which is more user-friendly to see. Moving down, reachability is useful for checking for any internet connection. And in this function, getParks, we check for whether or not we are connected to a network and if the URL can be generated. Otherwise, we return a specific error for each. If not, we can move on to request the data, and we can generate other errors accordingly if necessary. You'll see that data count and parkresult.parks.count both check for whether or not we received an empty list and notifies the user accordingly. Now let's head to the park list view controller, which is where we call all of these functions in park service. When we try to get the park result in the park list view controller, the code here checks for any errors and notifies the user with a localized error message if there is an error. This is done using the UI alert controller, which is set up on this line. If there's an error, the user gets the localized description of the error, which comes up as a clean notification. I implemented a refresh feature that allows the user to refresh the app if the Wi-Fi was initially down. I do this in view.load via let refresh control equal to UI refresh control. This calls getParks again if we pull down the entire window. So I'll do a quick demonstration of this. I'll turn my Wi-Fi off and launch the app. So what you'll see here is that we get an alert saying you are disconnected from the internet. I'm going to click OK, and now I'm going to turn my Wi-Fi back on. Once my Wi-Fi is back on, I'm going to pull down and refresh. It shows me this activity indicator, and now I'm going to be getting all of my data again. So the second feature I'll cover is the activity indicator that you just saw, which tells the user that the app is retrieving park data. I do this by setting up var indicator equals to UI activity indicator view right at the top of park list view controller, and I style this in the activity indicator function right here. I start and stop the indicator in the following ways. So I start the indicator using this function that I created at the beginning before any single time that I try to get parks. And then if there's an error, I stop the indicator. Otherwise, at the end of trying to get parks, if that worked, I also stop the indicator from happening. You'll see it in the simulator here. If I click on a cell and I go back, you'll see it appear for a little bit before all of the data loads. Now let's talk about constraints. I'll go to the main storyboard for this. So you'll notice that when I rotate my app, the visual should still be visible. I'm going to rotate this. The visuals are still visible. Takes a while to load, and I can scroll down. If I open this up on an iPad, it should also show up as proportionally sized, as you'll see here. The text is a little bit bigger, and when I rotate it, it's the same. I'll explain how I did this using constraints. I'll open all of this up. I've pinned the scroll view to the root view so that the scroll view's leading, trailing, bottom, and top edges match up exactly with the root view. I also pinned the stack view, which contains all the labels and the image, to the content layout guide and frame layout guide. This means that the content will stay rooted in the top left corner even after rotating or expanding to a larger screen. But what about sizing? In order to make sure that the image is seen on both a vertical and horizontal screen, the multiplier for the width, as you see here, has to be equal to 1, and I did this for height as well. On landscape, we set the height to be the height of the screen when height is compact, so that I can see the entire image without having to scroll. And we do the same for width in portrait mode. Now this means that I am able to see the image on both orientations, and the image resizes based on the device used. I've also made it so that the font size on a larger device is proportionately larger, which is done via customization in the right column. So that's all for constraints. On an iPad, you saw that everything was still proportionately sized and visually good. Lastly, let's talk about tests. There are 3 main tests here to track the flow of data through the app. First, we have park test, which is a unit test that looks at the debug functionality in the park class. We want to check that the debug description works properly for when instances of the park should be represented while debugging. So here we have a sample park, we get its debug description, and we check that this is what we expect it to be using assert equal. Next, we have an integration test named park service, which checks that the data is passed correctly from the API to park service. Here, when our system under test calls getParks over here, we wait for parks and error. We want to check that we get parks back, no errors, and that we get this back in a timely manner. So let's try running this. And we'll see that it passes. Lastly, we have the view controller test, which checks that the table list is being populated correctly. First, we instantiate a storyboard and a navigation controller, and assign the park list view controller as system under test. Then we launch the app and trigger the view, and assert that views are not nil so that we can test them right now. We then make a mock parks array as a correct test double to test on, run views did load, and inject our mock parks service into the system. We need to assert that before loading the data, we have no rows because no data has been loaded. After loading, that is, after view will appear, we need to assert that mock parks has the same number of parks as the system under test, and also assert that we have the same number of cells as the number of parks. This addresses a key vulnerability, as cells are recycled as we scroll through the list, and we should have the same number of parks as the number of cells seen plus 1 at any given time. So we'll run this test. And it passes. So that's about it for this app. I hope this gave a relatively clear overview of its features and functions, and thanks for listening.